The final part of section 7.4 in your lecture notes is about graphing functions of two variables, essentially surfaces. And we're going to see that when we have z equaling some f of x, y, x and y being variables, we can have surfaces. For example, the surface of this world famous magical ukulele that allows you to travel in time, appear and disappear. Unfortunately, there is no single set of equations that can describe this ukulele because of its incredible uniqueness, but we'll see on the board and also on a computer, and you can do it yourself. I'll show you how, that by using software called topcat and the grid that you can find on Moodle, you'll be able to copy-paste conditions that you find in the lecture notes to visualize and manipulate these surfaces. Not quite this ukulele, but ellipsoids, cones, cylinders, and other weird surfaces. Well, first of all, you know the drill. We need to get rid of the ukulele. Unfortunately, the song is still not going well. We can then get rid of this and go to graphs of functions of two variables. Much more useful now. Let's start with an ellipsoid. How can you describe an ellipsoid and write it in a form something like z equals f of x, y? A way to do it is an ellipsoid is kind of a surface version of an ellipse. We can write an ellipsoid by writing x squared over a squared plus y squared over b squared. This would be similar to an equation for an ellipse, and it is an ellipsoid because we also have z and divided by c squared, and this is equal to a constant, let's say equal to 1. Typically for these surfaces you could go on and you can draw a z and x and y. In this case, I will not be brave enough to draw it an ellipsoid, and therefore it's much easier to use some magic and make it appear here for you to see. And you can also check on lecture notes, that's in 7.4.1. You have a decent representation of what an ellipsoid looks like. And specifically, you can transform an ellipsoid into a sphere if you set A equals to B equals to C. If you do that, you get the surface of a sphere. By using topcat, which I'm now magically showing you, you can load the grid that is available on Moodle. You open it, and in the subsets, which I'm also trying to click virtually and showing you what you need to do, you can create a new subset within this grid. This grid, if you want to think about it, is sort of defining some space-time that you can then apply conditions to. So you highlight those points that satisfy conditions like those of an ellipsoid. If you plug in those conditions, and it helps to use things like lower than, because then it highlights the volume, it's easier to see. But you can also set it to equal to, or maybe define a range so that your surface has a little bit of thickness and it's therefore easier to see. If you succeed, it should look something like this. And if you develop some superpowers, you can even rotate it like this, or like that, or like that. And you can even change the contrast, change the color. For example, with your own mind, you can change from blue to green to red. It's amazing. Physics 101 magic keeps on getting better and better, and now you even have access to it.